So, when we move on to terminal alkynes, so we have a hydrogen atom in the terminal alkyne, and this hydrogen can be actually donated or given as a proton to some other substrate. So, when this hydrogen can be given out, then we call this as a acidic substance. So, this is what we have seen according to Lowry-Bronsted theory. So, the terminal alkyne hydrogen can be reacted with the base, any base, especially we have a strong base like sodamide. This gives the corresponding sodium salt along with ammonia. In other words, the hydrogen can be transferred to another base. This type of reaction makes this terminal alkene as a acidic substance. So, that is what we say, the terminal alkynes are acidic in nature. And how or why this kind of proton transfer takes place, if you look at, basically alkyne contains triple bonds, that means 1 sigma bond and 2 pi bonds. In other words, we can say there are high electron density that is present in the alkyne system. So, when there is electron rich species, they can actually donate the hydrogen can be lost as a proton. So, that is what actually happens. So, we may assume that this high electron density on alkyne may be considered similar to electronegative atoms. So, whenever we have an electronegative atom, what an electronegative atom does, if we have hydrogen halides, so the X tried to pull the electron towards itself and the hydrogen is lost as H plus. So, this is what happens in the case of HX type of molecule. Similar to that, in the case of alkyne, when we have hydrogen and the electron rich species, that is the alkyne, when it is present, this wants to keep the electron towards itself. So, the hydrogen can be easily lost as H plus. In other words, we say this can behave like a acidic substance. And when we look at the relative acidities, of course, water is having much more acidic compared to acetylenes, and ammonia is basically a basic substance. So, this is much less acidic, and alkanes are even much less acidic. So, in other words, the hydrogen in the alkane is very difficult to replace. So, that is what we say, this R and H plus, if we have to go here, R as a minus, if this break has to happen, then those kind of systems can also be called as acidic, provided if this hydrogen can be easily replaced. Since alkyl groups cannot give away the hydrogens very easily, they are less acidic, whereas in the case of alkynes, they can easily give away the hydrogen. So, they are more acidic compared to alkanes. As we say, why the acetylene hydrogen is acidic. So, we can say here, when a strong acid gives away a proton, we end up with a weaker base. So, that means in the case of alkynes, this is an alkyne. So, the alkyne and the acetylide anion are formed. This is basically happening like an equilibrium reaction. And when we look at the alkanes, this is another examples we just discussed earlier. So, when alkane gives out H plus ion, we end up with a stronger base. Ethide ion is a very strong base. So, in this particular system, the reaction proceeds via this direction and not in the forward direction. So, that is also one more reason is, in the case of acetylide, we have a sp hybridized system. So, it is more stable compared to the sp3 hybridized methide anion. So, that is the reason, even though this is a weaker base, this is more stable and this is less stable. So, since this is more stable, this reaction occurs very effectively, and that is one of the reason acetylene can easily give out the proton or the hydrogen, whereas an alkane cannot give that hydrogen that easily, because we are going to end up with a stronger base, but a less stable base. So, that is the reason in the case of alkynes, they can easily give the terminal hydrogen very easily. In other words, they are acidic in nature. Let us look at some of the reactions of alkane. First, let us look at alkylation reactions. So, as we mentioned, the terminal hydrogen is acidic in nature. So, this hydrogen can be easily replaced by metal. and when it is replaced by a metal, reaction with an alkyl halide leads to the substitution of the alkyl groups. So, alkylation of acetylenes, especially having the terminal hydrogen, is easily carried out in the presence of strong metals like lithium, and this intermediate whatever is formed is called metal acetylides. This reaction actually works better in the case of primary alkyl halides, but the metal acetylides are actually basic in nature. So, in the case of secondary and tertiary alkyl halide, what happens is elimination reaction competes along with this particular substitution reaction. So, that is the reason in those kind of cases, especially in the case of secondary and tertiary alkyl halides, they are seldom used for the alkylation reactions. And when we talk about the terminal hydrogen reacting with the Grignard reagent, so ethyl magnesium bromide is shown here as an example here. So, here the hydrogen actually is acidic in nature. So, this acidic hydrogen reacts with the ethyl magnesium bromide to give ethane as one of the product, and we get the corresponding Grignard reagent attached to the alkyne system. So, this is one of the reason when we talk about Grignard reagents is getting cleaved using acidic reagents. Say for example, when we are preparing the Grignard reagent, we generally avoid use or presence of water or any acidic substance. The reason because this particular ethyl magnesium bromide undergoes conversion to the corresponding alkane. So, this is basically a side reaction in the case if we are using for normal Grignard reagents. But in the case of alkyne, this is a very useful method. We can actually exchange the hydrogen to give additional Grignard reagents which can be prepared using this method.